Turkey is a transcontinental nation, as it is located in two continents with the predominant part in Asia and the smaller part in Europe. It is the third most populous country in Europe, behind only Russia and Germany. Turkey's economy is mainly made up of agriculture, industry, and services. The main export products are clothing, fruits and vegetables, iron and steel, motor vehicles, fuels, and oils. But the greatness of this nation is also shown in engineering. Turkey is home to the fourth longest suspension bridge in the world and the second longest in Europe. It's the Osman Gazi Bridge, a structure that's 2,682 meters long. This is Construction Time. I'm Luciano Guimarães, and in this video, you'll learn how Turkey built the fourth largest suspension bridge in the world. The Osman Gazi Bridge is located on the southern coast of the Mediterranean Sea, also known as the Sea of Marmara. It is a sea that separates the Black Sea from the Aegean Sea, thus separating the Asian part of Turkey from its European part through the Bosphorus and Dardanelles. It is a suspension bridge that crosses the Gulf of Izmir at its narrowest point, 2,620 meters. This incredible structure connects the Turkish city of Gebze to the province of Yalova and carries the O5 highway across the Gulf. It was inaugurated on July 1, 2016, and became the longest suspension bridge in Turkey and the fourth longest suspension bridge in the world. In terms of the length of the main span, which is 1,550 meters, the bridge not only has a length of 2,682 meters, but also a height of 36 meters and towers that are 250 meters tall. The bridge has 6 lanes, 3 in each direction, and together with the Gebze and Izmir highway, it connects the cities of Istanbul and Izmir. But how did Turkey, a country with an unstable economy and high inflation, decide to carry out this mega project, which cost about $1.3 billion? Yes. For many years, the president of Turkey, Recep Tayyip Erdogan, and the Yildirim Group, a family conglomerate of mining and maritime transport companies, have advocated for the expansion of the country's airport and road facilities in order to achieve better connectivity between the provinces. In April 2009, an international competition was held that awarded the construction and operation of the bridge to a joint venture formed by 5 companies, including an Italian construction company. The Osman Gazi Bridge was part of an even larger project, a 409-kilometer highway complex between Istanbul, the largest city in Turkey, and Izmir, the third most populous city in the country. With the construction of the bridge, the distance between these two cities was reduced by approximately 140 kilometers, bypassing the long route around the Gulf of Izmir. The purpose of the construction? It was to reduce the travel time between the two cities from 8 to 4 hours. Initially, it was planned that 2 high-speed railway tracks would cross the center of the bridge, but this idea was abandoned in favor of creating a 4th lane in both directions. The bridge was made possible by a highway privatization program that has already invested $7.3 billion in road rehabilitation and highway construction in the country. In 2010, a contract was signed for the construction of the project, but it was only on March 30, 2013, that the cornerstone of the bridge was laid to mark the beginning of the works. But what were the challenges of building the 4th largest suspension bridge in the world? The construction of the Osman Gazi Bridge lasted 39 months and involved the dedication of more than 8,000 workers, including engineers and specialists from various fields. The pillars and the structures that support the ends of the bridge are made of concrete, and the decks are made of steel. 85,000 tons of steel and 125,000 cubic meters of concrete were used. In order to anchor the abutment structures of the bridge, Cofferdam structures were built on land and transported to the dock areas with the help of trailers. The design of the bridge consists of steel decks connected in a way similar to Lego pieces. It was designed this way to give the structure seismic resistance, a crucial consideration given the region's high propensity for earthquakes. That's why the bridge is continuously monitored by 390 strategically installed sensors. In addition, the structure incorporates sensors that assess the level of humidity and the risk of corrosion in the steel components. Internally, each deck is equipped with climate control systems that limit the humidity level to 40%. Both the steel pillars set on concrete bases and the concrete pillars were designed to withstand tremors. To mitigate seismic effects, pillars rest on what we can call layers of gravel, which act like cushions to absorb the transfer of seismic energy to the bridge structure. The architectural design also incorporated aerodynamic concepts to provide greater stability and resistance to the wind. A large part of the structure is prefabricated and was assembled on site, with the decks, for example, being designed in Romania. But despite all the precautions and the modern technology used, on March 21, 2015, during the construction process of the bridge, a walkway detached from the connecting cable bolted to the south tower and fell into the water. The walkway was essential to allow workers to access the opposite side of the bay. Fortunately, there were no injuries in the incident, as activity in this area had been suspended due to adverse weather conditions, including strong winds. After the incident, maritime traffic to Izmirti Bay was temporarily suspended for safety reasons. Operations resumed after the cable was recovered on March 23, 2015. The waterproofing of the bridge was a particularly unusual process on this project. It was necessary to provide strong and lasting protection in order to reduce the need for future maintenance. Given time constraints in the nature of the structure, the waterproofing system for the bridge deck also needed to allow for quick and easy application and have minimal environmental impact throughout its lifespan. For this, an advanced waterproofing system was used, which took 4 weeks to apply. In addition, a high-friction coating system was applied to the bridge walkways to provide a durable, non-slip finish. The practicality of applying the system, combined with the fact that each element of the waterproofing system cures in less than an hour, help to facilitate the progress of the work. The technology used for waterproofing provides a strong and durable membrane that withstands the toughest conditions. This extends the lifespan of the bridge and reduces maintenance costs. The construction was completed on June 30th, 2016. With the bridge, it is possible to cross the Gulf of Izmirte, in just 3 minutes instead of taking the ferry ride that lasts an hour or taking the overland detour through 100 kilometers of heavy traffic. The long Istanbul-Izmir road, of which the bridge is a part, reduced the average travel time between Izmir and Istanbul from 10 hours to about 4 hours. The travel time between the country's second busiest airport, Sabiha, and the eastern region of the province of Izmir, in Bursa, has also been reduced to less than an hour. An important fact is that the bridge was designed to curve to the right after the section that passes through the city of Altanova. So why wasn't the bridge built in a straight line? Before we answer the question, let's make a comparison with some bridges here in Brazil. In Brazil, there are several bridges that can be considered major engineering highlights, but the largest suspension bridge in Brazil is the Eliseu Luz Bridge, located in Florianópolis, Santa Catarina. It is 821 meters long, which means it is 3.2 times shorter in length than the Osman Gazi Bridge. In addition, the central span of the Eliseu Luz Bridge is 339 meters, which is 4.5 times shorter than the central span of the Osman-Gazi Bridge. Now let's find out why the Osman-Gazi Bridge was not built in a straight line. It turns out that when building the bridge, the Turkish Ministry of Transport took into account the topography of the cities it crosses in response to concerns raised by the Ministry of the Environment. The latter warned that the regions crossed by the bridge, such as Istanbul, Izmir, Bursa, and Yalova, are characterized by dense forested areas, and they serve as a route for migratory birds that travel to Turkey during the summer and winter seasons. To give you an idea, the Hesek Lagoon, which is located in Altinova, has a very rich ecosystem and is frequented by flamingos and other bird species. That's why the bridge project took into account the potential disturbances that construction and vehicle traffic could cause to these birds, resulting in the final design of the structure with a curve in this section of Altinova. Furthermore, if the structure were built in a straight line, the residents of the cities near the bridge would be deprived of enjoying the natural beauty of this region. The Osman-Gazi Bridge is, without a doubt, a great achievement of modern engineering and a very useful structure for the Turkish population. Currently, the bridge receives a daily flow of no less than 40,000 vehicles. The Osman-Gazi Bridge in Istanbul caused an increase in the value of land and real estate in the region. The prices of these properties, located in the areas around the bridge and the road, have increased by up to 400%. There was an unprecedented increase in construction in the area, not to mention the interests of new investors. We can say that the entire region became more valuable after the construction of the bridge, and there was also an increase in commercial establishments and more job creation. Despite the criticism of carrying out and maintaining a project like this in an area highly prone to earthquakes, Turkey is reaping good results thanks to the bold decision to build this bridge. The construction of the Osman-Gazi revolutionized the advantages between the north and south of Turkey. Soon after its inauguration, the bridge quickly became a route of heavy traffic across the country, both for local residents and for global companies. Goods between Asia and Europe. Thank you for watching this video this far. Did you know about the Osman-Gazi Bridge and that it is the fourth largest suspension bridge in the world? Leave a comment below if you did or didn't, and also leave a like if you enjoyed this video. Subscribe to our channel if you're new here, and that way, you'll always be up to date on engineering around the world. That's it for now. Take care, and see you in the next video.